This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
My journey into becoming a UC Santa Cruz's faculty climate action champion started with the students, and in fact they started with students with a dream. These are a group of students part of the Engineers for Sustainable World at Santa Cruz, and they had a dream that they wanted to build an electric race car. Which is an ambitious dream, but they were a very talented group. But the issue they had was that they couldn't actually find any facilities to build their electric race car. Right? They had no place to do it on campus. They weren't doing it as part of a faculty project. They basically had no place to go. So they started a petition. And the petition was very simple. It said UCSC should more actively support on-campus extracurricular organizations in their pursuit of relevant hands-on engineering projects. And they got a few signatures, and a few more, and a few more. And they ended up getting well over 1,000 signatures of and that's basically a majority of our engineering and physical and biological sciences divisions, or physical science divisions, to say that we need more of this on campus. And there were a lot of staff that were very passionate of helping to support these students. I show a couple here: Tamara Ball, Kevin Bell, the Sustainability Office, Melissa Ott's here, Chrissy Thormun's here. And also this guy here, next to the gorilla, Ronnie Lipschitz, who's a faculty member in politics and also started a sustainability minor. His vision, the S Lab, which I'm going to talk about today, is his vision. But he needed somebody to help with a little tiny problem. And that is, we've got people passionate, we've got students who are passionate, they even can raise some money. But what do we need is the space. And that's where I came in, because I had space I could provide for these students. And to give you an idea what these students want when they ask for space, I'm going to show this video.
Hi, I'm Kelly, and this is Formula Slug. We are trying to build an electric vehicle in under 6 months for the FSAE competition in Lincoln, Nebraska.
We are an interdisciplinary group of students working to innovate renewable energy technologies. We have cultivated a strong team dedicated to research, development, and production of these technologies. Not only do we plan on building this vehicle, but we hope to provide this project as an educational platform to give students the opportunity to apply their diverse knowledge in real-life application.
Okay, and I want to go repeat what you just said. But the whole point of this was to apply their diverse knowledge to real-life problems. And so the S Lab is a facility that allows students to be able to do that when they didn't have any access to other facilities. So you can get an idea of what they needed. They needed a place to basically build things and put parts together and weld things, et cetera. And so I basically turned over my applied physics lab. This is where it is. This is them working on it. It's in third floor team, and it's kind of an old lab. You can see it has an old Tesla magnet in it, but it was suitable for their purposes. So the S Lab provides more than just facilities. It also provides a team of, I keep on messing this up. It also provides mentorship. We have a mentorship network of faculty and staff, and training for students to do research along the lines of sustainability. We have an indoor facility, which is on the third floor of Tiemann. It's 1,200 square feet. So Formula Slug and the Engineers for Sustainable World have about half of that, and the other half go to other projects. The nice thing about this, besides having all the equipment they may need to do some of their sustainability projects, is there's access to the roof. It's right below the garden type roof, so they can do outdoor measurements on the roof. And if you saw that race car, they need access to a freight elevator to bring their race car up and down the hallways of Tiemann. We also, students also want to do outdoor facilities. So I found, these are 2 of my greenhouses I had down at the Arboretum. I'll come back to why those greenhouses are there in a second. And this is a place where students can do outdoor projects. And in this case, we're looking at, these are both off-the-grid greenhouses, their own little microgrids. And we're working at aquaponics and LJ waste rays and range catchment systems and anything you'd want to do regarding that requires outdoor facility. One of the projects that's been going on for a while there is an aquaponics project, and we're starting to expand that even further. So these are the facilities that we've established. We've also been working on developing workshops and training modules just in case. The Formula Select students are pretty amazingly experts at most things. But we also wanted to be able to provide people training that they needed to have in order to do whatever projects they wanted to do. So we basically developed several different modules, anywhere from learning how to use Arduino and Raspberry Pi to build remote sensing networks, to building microgrids and understanding the basis of electrical code, to building rainwater catchment systems or wastewater management systems and understanding the basics of plumbing code. We have facilities where people can make their own devices if they want to, make their own supercapacitor and test it. And then, of course, we have Ubiquitous Computer. And we'd like to extend this stuff we're developing right now. We'd like to go work with ASICI and get some training on how to set up field studies trials for some of these students, and as well as work with the machine shop. As you can see, the machine shop is a pretty critical component of a lot of the sustainability stuff that's often overlooked by us faculty. So in addition to the S-Lab, I've been working on marrying the S-Lab with a center I run. I run the Center for Innovation and Entrepreneurial Development at UC Santa Cruz. That means I help students launch their ideas into startups or other innovations. And the idea was to basically make the S-Lab then into a maker space for student innovators. And give you an idea of where I identify these student innovators. These are some of the events we run. We run the Pitch Slam, which we just renamed it the Slug Tank recently, which is where students get up and pitch their ideas for 3 minutes. We run the Hackathon, 550 students. It's actually got entirely filmed on, PBS came in and filmed their entire 48 hours at our Hackathon. So if you want to see UCSC on TV, it airs in October if you see the Beyond Geek show. And then we just finished, in April, I just finished running our Business Design Showcase in Silicon Valley with 16 teams. And we just launched our accelerator, our Summer Entrepreneurship Academy, which will start this summer. So this provides a framework for our entrepreneurs, whether they're doing sustainability or other areas, to basically move forward. So I want to go back to this idea of why the S-Lab might also make an innovation test bed. So you might see I had these conveniently couple of greenhouses sitting in the UCSC Arboretum that I could hand over to the students in some sense, right? You might ask where they came from. And the fact is I was using the campus as my own little test bed. This is what I started with. It's a technology we're developing. And this is where we're now sitting at. So I don't need those greenhouses anymore because we're installing in this. And our technology is very simple. It's a photovoltaic panel that you can install into the roof of a greenhouse. We only take out the light, the green light that plants don't use. They're green because they reflect that light. And we convert that directly into power. Then we let through and enhance the wavelengths that plants do use, which are basically blue and red. And that allows us to basically potentially enhance the plant growth, or at least keep it neutral. So this allows us to basically use the same piece of land for both power production and plant production. And in addition, there are significant capital savings involved in this because you're reusing the frame. Basically, the frame of the greenhouse itself provides the frame for the PV panels. In addition, because there's a 30% tax credit on installing PV right now, that gives you a way to basically get a tax credit for the greenhouse that you're installing. So there are a lot of benefits to this. And so finally, I just want to basically say that we have a S-Lab. That's what I did with my 1 year or my 6 months into my Climate Action Champion thing. And we've got some facilities, and we're hoping to get a whole bunch of student innovators at our site and hope to support them there. Thank you.
My name is Santana Vergara. I am a postdoc in Wendy Silver's lab at UC Berkeley. And today I want to talk to you about an extremely low-tech solution that we've been working on in the Silver Lab. Okay, so a lot of people may not know that we are near a tipping point. This is from the latest IPCC report, and they state that a large fraction of climate change is irreversible on a multi-century to millennial timescale, except in the case of a large net removal of CO2 from the atmosphere over a sustained period. So what this is saying is that reducing our emissions to zero is actually not enough. We need to do it, but we also need to find a way to take carbon out of the atmosphere where we don't want it and store it somewhere else where maybe we do want it. So one option for storage is in our soil. Soil is already the largest terrestrial carbon sink, and it stores more than the atmosphere and vegetation combined. So if we think about this challenge from the IPCC, maybe we can take carbon out of the atmosphere and store it in the soil. Most managed lands right now are degraded with respect to carbon. So that means that there is potential for these soils to store more than they are right now. This is probably a familiar graph to most of you. It's the Keeling curve. On the y-axis, it shows atmospheric CO2 concentrations, and the x-axis is time, starting in the 1950s. And this graph shows us two main things. The first is not surprising. CO2 concentrations are going up. The second thing it shows, though, is this interesting annual cycle where CO2 goes up, CO2 goes down, CO2 goes up, CO2 goes down. And what's happening there is photosynthesis. So when plants grow in the spring and the summer, they're using energy from sunlight, they're taking up CO2, and they're releasing oxygen. As they take up CO2, the global concentrations of CO2 are dropping. And then in the fall and winter, when these plants senesce, die, decompose, they're releasing it again. So if we return to this challenge from the IPCC, can we take carbon out of the atmosphere and store it somewhere else? We actually know that this is already possible, and plants are already doing it. But can we find a way to enhance that natural carbon sequestration that's already happening? So when we thought about an experiment to test this question, the Silver Lab started by talking to farmers and ranchers because they know a lot about their soil. And we asked them, what do you do to increase the carbon in your soil? And they said, compost and manure. So we listened to them, and we took two very high-emitting sources of waste. On the top, we have a landfill. So we took food waste, diverted it from a landfill where it would ordinarily emit powerful greenhouse gases like methane, and took manure, which would ordinarily go into these anaerobic ponds where they'd also be releasing methane and nitrous oxide, and we instead rerouted them. So instead of them being waste, they became a feedstock. We composted them, and we applied the compost to grasslands in California. And what we found was very surprising. So we did a one-time application. I want to stress this, just one time, 1/2 inch of compost in 2008. And we measured, on the y-axis here is net primary production. So that's fancy talk for plant growth. And on the x-axis, we have time. So we applied once in 2008, and then we can see that for every year we measured since, 2009, 10, 11, 12, the composted plots grew more plants than did the control plots. So that's very exciting, right? That means that these plants are photosynthesizing more, they're pulling more carbon out of the atmosphere. But you might be asking yourself, well, maybe we're growing more plants, but maybe when these plants die, they're just re-releasing all that carbon back to the atmosphere, and that's not much of a sink. But no, we also measured soil organic carbon. So on the y-axis, soil organic carbon, and the x-axis, again, is time. And I want to stress again, one-time application, 2008. And we measured soil organic carbon, and we found that soil organic carbon in composted plots was higher than soil organic carbon in the control plots. So this shows that this one-time application at this site in Marin, California, led to the movement of carbon from atmosphere to plant and into the soil. We also did a life cycle assessment looking at the net greenhouse gas emissions from the use of compost as compared to the use of manure and fertilizer as soil amendments. And the key takeaway from this slide is that compost is the only greenhouse gas sink of the three. And the main benefit from compost actually derives from what I mentioned earlier. We're diverting what would ordinarily be waste in a very high emitting stream. The food and the manure, instead of becoming sources, are becoming sinks of greenhouse gases. One other thing I want to point out about this slide is that the red bar that you see over here in the compost is actually very highly uncertain. We don't have a good handle on emissions from the composting process itself. So that is one of the projects we're working on now. We have highly instrumented compost piles in Marin County again, and we're continuously measuring nitrous oxide, methane, and CO2 from the pile. And we have two basic science questions. One is, what are the greenhouse gases that are emitted during composting, and how much is emitted? And the second question is, can we understand what the key drivers are of these emissions? What are the variables that lead to the emissions of these important greenhouse gases? And if we can understand these variables, then we can understand how to minimize emissions from composting. So one example of a variable might be the ratio of manure to woody waste, or basically the nitrogen to carbon ratio. We're also very interested in scaling up our results and seeing to what extent these might apply to a larger scale. So in California, we're doing a modeling exercise where we're looking at the best use of organic waste feedstocks in California, so food waste, green waste, manure. We're also doing some field experiments where we are looking at how soils and other rangeland ecosystems might respond to compost addition. And finally, at the global scale, you guys should check out Allegra Mayer's poster because her PhD project is looking at whether changing land use management can reduce the Earth's temperature by 0.1 degrees C. Thank you very much, particularly to our funders.
All right, well, I'd like to thank everybody for the opportunity to speak today. I'm Skip Pomeroy from UC San Diego. And I'm going to talk to you a little bit about the algae-based surfboard we made. And there's the crew from the San Diego Science Festival. We had 25,000 people come by. And so part of the story I want to tell is, I think, how do you reach other people with stuff that I think all of us in this room think is important, but how do you get everybody else engaged? I'm the member of two different big science centers on campus. One is the NSF Center for Chemical Innovation, the aerosol impacts on climate and the environment. Another one's CalCAB, the California Center for Algae Biotechnology. And these two centers clearly are related to climate change and the environment. And in my Climate Champions output here, we're working to make nice small instruments based on Arduinos and Raspberry Pis that can go out into the environment and sort of spur on the idea of scientific inquiry. When you're looking at the next generation science standards, it's all about inquiry-based science, except for very few of the teachers are trained that way and very few of the labs have enough materials to do that kind of stuff. So that's one aspect of this. So you're looking at a particle counter here. We've got a Brown particle counter and a pH meter here that works off of your Bluetooth from your cell phone. What I want to spend today talking about, though, is making a sustainable surfboard. And so, in case we're looking at aerosols, right, and mostly it's try to figure out, cloud composition and see what effects those things have on rain and where it falls and the energy balance in the atmosphere. And for CalCAB, right, one of the things we do a lot is these student-based projects, and so one of them was shown here is our algae biofuel, where we made a 1 barrel for Baja. The goal was to make 35 gallons of algae-based biofuel to put in a diesel motorcycle to run in the Baja 500, right? And once again, you get people excited about doing something that looks more relevant than if you just say, oh, I made some biofuel in the lab. So, we actually run this thing, and you can actually have the land speed record, right, for a diesel motorcycle, which is not really all that frightening because diesel motorcycles don't go that fast. Okay, now there's a series of 3 slides here that I always feel like wanting to shout to everybody every time I talk to them. And we talk about climate change, and I'm not trying to minimize that. That's horribly important. But I never understand the idea that nobody gets the idea that the petroleum's going away. It really doesn't matter. In a weird sense, we're conducting this experiment, and if we all just argue until all the petroleum's gone, then over a course of a couple hundred years or a millennial or so, it'll take care of itself anyway. And so, the question, when is the tipping point, is really only the thing that's up for debate to some degree, right? This petroleum is going to go away. Why do I worry about that? Is because if you overlay population over on top of fuel that's been generated, you can see that they sit right on top of one another. And so clearly, if fuel starts to become in short supply, then clearly that's going to have some effect on human populations. And I think this slide, the next slide here, is even more to that effect. If you plot food prices and oil prices on one another, these are really highly correlated. So the idea that fuel, right, drives the way that our world works and our social well-being is really important. The problem is that when you have fuel that's now down at $30 a barrel, right, you can't really get the biofuel industry going anyplace, whether you're looking at ethanol, cellulosic, or biofuels from algae. You know, when this was trading up around $120 a barrel, this is fungible, but when it's down at $30 and $40 a barrel, it's not. And so the question then becomes, you know, on this curve here that was predicted, it's actually stayed pretty much true to form. And so for the next year or so, we don't expect to see any real change in the oil prices, which then just stops. We were talking at lunch about venture capitalism. There's not a big environment for a lot of venture capitalism in biofuels when petroleum is trading at $40 a barrel. So the question is, now what? Right? You know, we've sort of got this infrastructure and we're interested in these things. And so here I've just pulled up, people have been doing this stuff, making renewable polymers for a long time, and they're out there. And so our goal was to look and say, okay, if we can't make fuel fungible, can we do something else of higher value with this stuff? And so some of it's making proteins for food, some of it's making drugs and other things for food and for medicines. But we're looking at something saying, okay, but I need to go scale up some, right? Not just little stuff for drugs and medicine, but to look at something a little bigger. And so we're looking at the polymer industry for polyols in particular. So what we want to do is say, okay, can we take, when we go to grow all this algae, can we find a way to make something of higher value? Maybe not as much as a protein, but make something of an intermediate value so that we can also go to scale, right? Because if we can't go to scale, we're never going to be able to figure out what the real costs are for our endeavors in this. So we're going to start off with the oils that we had from before, and in these oils there are these functional groups, these double bonds in here, which we can modify. And so if we modify these things, we can take this algae oil, right, this is just a plain old triglyceride, and we can then modify them so that they can be used in polyurethanes, polyolefins, amides, nylon, polyesters. And so the real trick is, can we take these things and make them into something that works? One of those problems that you come across is the issue of what's called a drop-in fuel, right? So that worked for biodiesel, but on the polymer thing, when you go to make a polyol, you can chemically make this compound here, and it is indeed a polyol, and you can calculate a hydroxyl number associated with this thing, but you can't take the formulations and drop them right into the polymer industry, okay? The polymer industry is really built around the petroleum industry, and so stuff that was distilled out that didn't go into a gas tank, they found another way to turn it into the kind of monomers that they delivered for the petroleum industry, from the petroleum industry to the polymer industry. If you don't change the toolbox, then there's no way to change the way things work, okay? And so for what we're finding for these biopolymers, you can't just drop them into existing formulations. And when you start to talk to people like at BASF or Cargill, they're going to ask you how many millions of tons do you want to buy, not how small, they're looking at that kind of scale in a market. So small things don't really matter to them in any way. So we're basing our ideas off the idea that we're going to work out the chemistry and try to find all the unique small molecules. There is way more diversity in biopolymers than there are in petroleum polymers, actually. So where did we want to head first, right? So we sort of looked at this from a market point of view of saying, which group of consumers would be the most interested in actually paying the money for these things? And so we targeted the outdoor sports industry. And in particular, the beauty of a surfboard, which is what we're going to talk about here in a minute, is that surfers are already pretty environmentally friendly people, and they always had this one problem of they're riding around on a piece of petroleum that lasts forever in the landfill, right? So while they want to be conservationists, they're actually doing something that's counterintuitive in that regard. What we've made is a foam that's biodegradable, but you also have to hit the performance criterion. They want foam that's very hard, really lightweight, right? Got small cell size so you can shape it down really finely. So for us, this created a challenge chemically. Could we make something and tailor it to this industry that everybody be happy about? The other part that we thought that was important about a surfboard is that most of the cost in a surfboard is in the manual labor it takes to shape this thing. And so if you doubled the cost of the foam itself, it would go from maybe $10 to $20, but that would only be $10 extra in the cost of a surfboard that usually will run somewhere around $500. So we felt that this was a good thing for the consumer point of view, that they'd buy in for that small amount of money. So we've partnered with Arctic Foam, and we've started a company, Algenesis, where we've turned these algae oils into these polyols, which we made into polyurethane, and put them into surfboards, right? We've got one on display outside, you can see that we've had it on display at the boardroom. It's won awards for its sustainability. We're up at something like 36% of the replacement of the polyols in the surfboard. As soon as you're at 8% total renewable, the government claims that that's a renewable material, so we're over that. But that's also something you have to think about. But we believe that in doing this, we've figured out what tools we need, and our goal is to make a completely sustainable surfboard. Now, why is this a climate champion argument? Well, clearly there's the carbon neutrality that's associated with this. Polyols require less energy to produce. They produce less CO2 in their production, but it's also a platform for talking to people about this kind of idea, where I'm always puzzled, doesn't everybody know the oil's going away, right? But as long as it's $30 a barrel, no one ever acts like the oil's going away. And so to me, this is an opportunity for the platform for consumer education. Okay, and so that's really where we want to try to outreach people, talk to them about polymers. And you know, what I always find interesting is all the different ways you manufacture the same set of chemicals into lots of different products. So the squishy foam that would be in a mattress, and the hard foams, or the cases on the jewel cases for a CD player, these are all basically the same monomers. It's about process is what makes them all very different. So with that, I'd like to thank you for your time. Over here, we've got all the people that work in the lab to try to make the polyols. Over here, we've got the group of people from Arctic Foam and all the fund managers who do all the great work of keeping me out of trouble with my financial support, right, which comes from the Department of Chemistry and the Climate Action Champion and Food and Fuel for the 21st Century. And what you see here is at the San Diego Smartest City premiere from the National Geographic thing, we presented algae-based surfboards to the mayor, and this is Rob Machado, a professional surfer. And what was interesting about these things is no sooner as we got them, they were supposed to go around the world and tour where this was opening, and then it gets to the Japan Airlines, and he took it, and every time we make these boards, they disappear, right? And so I think there's some value in these things. People starting to find them as a real novelty thing. Everybody seems to want to take a picture with them. And by the way, during the poster session, we brought a surfboard down, so if you want to come and take a selfie, you're more than welcome to. All right, with that, I'd like to thank you for your time.
My talk is going to be about sponge suit and then rechargeable batteries from sustainable resources. And of course, the motivation is coming from the climate change and how we can reduce the carbon dioxide emission, and as engineers, what we can do in the lab. And this is something that is, I think everybody is familiar in this room, you know, showing the atmospheric carbon dioxide emission going up yearly, and that impacts also the seawater concentration, because about 25% of the carbon dioxide in the atmosphere is being absorbed by oceans. So that's why the concentration of carbon dioxide inside the oceans also going up. So what happens if the carbon dioxide concentration goes up inside the ocean? Simply is you are making the oceans more acidic. So that's the fact that we are living today, and we are making our oceans more acidic. And if you look at the numbers here, actually, this shows since the beginning of the industrial era, and the ocean has absorbed about 525 billion tons of carbon dioxide. And today, it's about like 22 million tons per day. So that's a lot. So this curve is going to continue going up, and then unfortunately this curve is going to continue going up, and this one is going to continue going down. So when you make, the chemistry change in the oceans, simply it affects the marine life. I just want to give a quick example from our, blood. And the human blood, it's around like 7.3, 7.4 in pH. And if we have 0.2 to 0.3, difference and drop in our pH, so we'll go into a coma and we'll die. So similar things will be happening in the marine life as well, which we need to pay attention and then, do something about it for sure. And that's one of the stresses, global warming, heating the surface temperature of the ocean and making acidic is one stress, and additional stresses are the oil spills. And many of us in our lifetime, we have seen, a couple of oil spills, and then we also see that how it impacts. So simply we know the impact on the birds and then the marine life, and they are all being impacted. And so we start looking into what we can do, how we can clean this mess from the ocean. And that's how we come up with this sponge material. And it took about 4 years for us to develop this material. And what you are seeing is that after an oil spill, majority of the oil stays on the surface of the ocean. And so we just want to see, if we have a super inexpensive, a cheap material that we can clear and take all the oil out of the ocean. So that's what is happening here. What you see on the left in blue color, it was the oil. And this is the sponge material. We turned that into like a flake format in this case, and trying to clean the oil on the surface of the ocean. So as you can see, we were able to take all the oil spill from the surface. But not the only, the oil spills just remain on the surface. Some of them actually goes under the water. And that's why we have to find a way of cleaning this oil spills or oil contaminants inside the depth of the ocean too. So that's why we want to make sure that our material works in the depth of the ocean as well. And so that's what we have tested here. So this particular oil contaminant is being cleaned using our sponge material also while it is at the bottom of the beaker. So I think myself and many of us said, if there's an oil spill, what can I do, right? Many of my friends keep saying this. And so that's why we start kind of like asking a question to ourselves, as a person, what can we do if there's an oil spill? So to personalize this technology, so we have developed the sponge suit and simply create a wearable technology that helps while you are swimming, you are also cleaning the ocean. So that's the main idea. And believe it or not, we entered this wearable technology competition in Rome. And there were about 70 applicants and coming from 25 different countries. And we got the first place. So people paying attention to this, so it was taken quite well. And the technology simply was using a 3D printing, and along with using our sponge material, which is kind of like acting filler, and just making a sponge suit. And of course, we have versions for men also. Because that's the question everybody asks, so I am just answering before anybody asks. And so this is, what we are trying to do and to save the oceans. But of course, by living in California, what we pay attention is that this carbon dioxide emission is really needs to be addressed. And then the main contributor here is the transportation. So for that reason, we kind of like want to, take the cars that are running on the fossil fuels, and if we can feed like electrical vehicles instead. So that's why you really need to have a good battery technology, and that's what we are trying to work on for more than 10 years, and develop a good battery technologies that can enable and take these, oil-based cars away from the streets, and we can use maybe EVs instead. So just want to show you, a couple of the technologies we have developed in our group. And one of them is called silicon nanofiber. And this technology aimed to, reduce the cost. Of course, the cost is always important. So by removing some of the unwanted materials in the battery system, so we were able to save the cost by 7%. And the weight is important, for example, especially unmanned vehicles, if you are trying to fly, or even in the cars, you always would like to have lightweight batteries instead of carrying the batteries, you want to carry the people. So that's why the weight is important. So we were able to, with this technology, reduce that weight also about 6%. And then this technology is being chosen as a top 100, received the top 100 seal by Nature Publisher. And our performance compared to Tesla's graphite anode is about 2 times better. And another technology we developed is the mono nanosilicon for the anode. And then the performance was about 4 times better than Tesla's graphite. And many people, especially industry, are asking, can you make something that we can charge this? You don't want to wait 8 hours to charge your Tesla, but rather than that, can we charge this in 10 minutes? And while you are doing that, you are not damaging the battery, you are not killing your car, and you just want to make sure that you have a very, very stable chemistry. So that's what we have worked on and developed the silicon cone CNT battery system with a great performance as well. And of course, considering the sustainability, we always wanted to look into other sources that we can use for the batteries, and especially sustainable resources. And that's what we start working on, the Portobello mushroom battery. It also received top 100 seal from the Nature Publisher, and we were able to replace the graphite with the material we produce from the Portobello mushrooms. And believe or not, this was in the Conan O'Brien show, and Conan believes that we came up with the idea while we are using a different type of mushroom. So I just want to answer this to make it public. No, we didn't. So we just looked at the microarchitecture of the basically mushrooms, and that's why we decided to use that, which is a great template for us. And other resources that we have used, the nanosilicon from the beach. As you can see, this is the true beach sand. And after processing, we were able to make batteries with the 3 times better performance as well. And another recent work, we use diatoms, which are biosilicon, and convert them into also a usable format for our batteries, and about 3 times better performance too. And since recyclability was one of my actions on campus, and my project was try to use recyclable material to make batteries out of it. And since more than 28 billion glass bottles and jars end up in the landfills every year, and that's equivalent of filling of 2 Empire State Buildings every 3 weeks. So that's a lot of material. And we were successfully actually take this recycled bottle and process that and make a battery with 4 times performance as well. And our group is quite innovative, and we produce literally a patent almost every few months, and all being licensed by different type of companies. And this is one of the company who took our patents and then make a battery, a real battery out of this, and it's a pouch cell batteries, which 35% better performance that you can use in your cell phones today. I think I need to finish, so I'm just gonna show just one thing. And as part of my climate action also, I work with all the sustainability directors of each campus, 10 campuses. So collected the data from each campus and put it together to make a comparison. So I'm gonna just make it quick here. So this is just showing comparison. You can find yourselves here. the Berkeley versus how people are doing, and then I'll just kind of like show where the UCR is, and then landfill waste. So we also looked into the landfill waste. So who's doing great, who's doing bad? Okay, so I am finishing, and then I just want to say that this is the end, and this problem that we have, climate act, basically warming is a global problem. So our atmospheres are connected, our oceans are connected, so we cannot ignore any kind of failure or disaster happening other side of the world because we are saying that we are too far. But Sue, let's work together and solve this problem. Thank you.
So I'm Kirk Kornbluth. I'm from UC Davis. We were the second highest emitter from that. I'm glad you pulled her off the stage before she was able to say anything else about us. We're the second highest emitter partly because we have the biggest campus and we have a med center. And it's interesting that the med center is not that interested in trying out new novel technologies and powering the hospital. Does that make sense to people? And that's something that actually we're working with in my program. So I started a thing called a Zero Net Energy and Climate Neutrality Education and Research Initiative. I sort of took it literally when the UCOP gave me this money. They said, we want to get to carbon neutrality by 2025. I was like, okay, so that's all we got to do? And we can keep the money? And so I work with campus. I was already doing projects. That's the reason that I got the money. I was working with facilities very closely to do Zero Net Energy on campus by 2030. So now we just had to do it 5 years sooner than we had already planned. So it's not that hard. And all we have to do that is develop a roadmap for climate neutrality, which is the action plan, do a bunch of modeling and figuring out how we're going to get there, right? Techno-economic social modeling. Okay, that's how we're going to get there. This is the technology. This is the behavior that we have to implement or get people to pay attention to. And then we could do a bunch of applied projects on campus, and then we'd be home free. It all starts here. This is my little lab at UC Davis. I started a thing called the Program for International Energy Technologies when I got my PhD. They say that if you get your PhD and you don't know what you're going to do, start a program and then appoint yourself the director. So I'm the director. Just turns out I'm a director of about 4 other things. There's so many directors at UC Davis, we can't even find anyone to do the work. Anyway, I started this little lab, and the reason I show you this lab is because really what I'm doing is I'm focusing on these projects, trying to get us to climate neutrality. It's great to see somebody who's been a big supporter here. And the other thing I'm trying to do is educate students in critical thinking, right? And I'm going to talk about what kind of critical thinking I think is important, but it's important for them to have a place to go that they can work and they can hang out and not work on their projects. They're there, they're working on their projects, they're interacting, and they come up with all kinds of different ideas, which is, I think, really important. We are in the largest planned Zero Net Energy community in the country, which is West Village. Good and bad things about that. The good thing is it's about 60 to 80% zero net. Is that a failure or a success? It's pretty good, right? We're producing almost all the energy on site that we use. It turns out that when you give students free electricity that they use more than they would if they had to pay for it. Okay, so there's some behavioral component there. I teach project-based courses which are not funded by the university. So if you want to do courses that are innovative, that are leading edge, that you can stop on a dime, that you can change the subject matter anytime you want, it's nice not to have to pay to be part of a department specifically. And if you want to do transdisciplinary work, and some other people talked about transdisciplinary classes, sometimes you just have to create them. So I appointed myself the director, and then I created a bunch of project-based courses, which I was paying for, and then I asked students if they wanted to come and take part in them. So that's what I do. And I created about 4 of these courses. A Path to Zero Net Energy is the course that I'm working with to get the campus to climate neutrality and zero net energy. We just started a new one called Pathways to Climate Neutrality with the physics department. And I teach 2 other classes here which focus just on energy and agriculture in the developing world. It's client focused. So we're trying to get the students around their head around this idea that these problems are not clean. They don't come to you well defined. So the students spend about 2 or 3 weeks just trying to work with the client to figure out what is the problem, right? And then the client has one idea about what they want to do. They want to replace all their buses with electric buses, and then maybe 3 weeks later the customer actually wants to use alternative fuel vehicles. So how do they educate the client? How does the client educate them to put this problem in some sort of frame that they can actually work on in 10 weeks? And we're on quarters, so it's only 10 weeks. This is the framework that we work in. I call it the 4 lenses of sustainability, which I coined that phrase, and I have copyright on it. So if you want to talk about the 4 lenses of sustainability, you have to talk to me. If you want to look at a project from a technical, economic, social, and environmental lens, you have to talk to me. It's the only way you can do it. You can do triple bottom line all day if you want. You can do it on your own. You don't have to pay me anything. But if you want to use the 4 lenses, so we have our students, we really want our students to understand that this is what you have to do to be sustainable. You have to talk about the cultural context. You have to talk about the technology, but not in a vacuum. You have to talk about the commercialization and the adoption. And then you have to talk about what are the environmental impacts. So if they have 2 designs that are competing, at least they know what the environmental impact of each one is and what you might do to choose it. So this is kind of what we're trying to do with them. It's international. I don't know if anyone here knows this, but the US is not the only people who are concerned about global warming. The US is not the only one who are implementing renewable energy. In fact, 10 years ago, I think we didn't even have that in our vocabulary, right? We work with the Danes who have been, some days they produce 150% of electricity in their grid. They're about 40% renewables in their electricity. We work with them. We work with other partners. And I think it's really important to have this international perspective. Our students are traveling. They're working both with European partners and are also working in developing countries. So, and that's the other side of it. We know that the climate problem is not just in the developed world, right? It's in the developing world. So we work on both of those. This is actually, I took the facilities manager from UC Davis to meet the facility manager in Denmark and talk about the way that they're managing their campus. So other news flash, all of the good stuff is not on the internet, right? All of the important data is not available through your laptop. And this is something we're also working with students to understand. Sometimes you have to make a phone call. Sometimes you have to travel. You have to do all kinds of different things. It's just one tool. But there's so many other ways to do it. So we really encourage our students to go out and talk to people. If it's on campus, they're talking to facilities managers, other people like that. If we're working at a project in Zambia, they're actually often traveling there. So that's really important. Learning by doing is another thing. I want students to get their hands dirty. I grew up in Detroit. I had my hands in cars from when I was about 12 years old. I like getting my hands dirty. I like creating. Most students do. Ever since they got rid of shop classes in high school, students have lost these skills. So they flock to my classes because they know they're going to learn how to use hand tools, maybe weld, whatever it happens to be. So I think that's the most important thing. It's also another way, another part of your brain to get in touch with for creativity is with your hands. And so we try to encourage that. This is UC Davis's vision for for 100% renewable. And this is starting in 2005 and going to 2025, which is right about the time that we're all shooting for, right? And what I talked about, UC Davis being a good place to work, is that they already have this vision and they're already moving on it. So it's not that hard. I didn't do this. I just inserted myself in a process that was already happening. I got students to work on on energy and climate projects, and I got to work with the offices at UC Davis who were already doing it. I think I was just fortunate that stuff was already going on and that everyone's willing to do it. So we're actually at Davis, even though we're the biggest one, or second biggest one, I think in about 10 years, you're going to be just above us over there at Merced. And just very quickly, some applied projects. This is my favorite project for students. The facilities came to us and they said, look, we have this big cooling storage where at night we create all our cold water for campus, right? It's an easy way to create cold water. It's an efficient way to do it. They have 5 million gallons. We created this thing. But we don't have a good protocol for when to fill it up or when to not fill it up. If it's a really hot day, should we start filling up a little before the end of the day so we have enough cold water for tomorrow? Or should we wait till tomorrow and fill it up during the day? What's the right protocol? So they came to us with that problem. We gave it to our students. The students looked at climate data. They went and talked to the operators. They looked at energy use data for the campus. They did a bunch of analysis. They did forecasting. They came up with a protocol for filling the tank, which saved the campus $40,000 first year and a bunch of energy, right? How much did it cost? Didn't cost anything. So that was awesome. When we interviewed, and this is the important part about going and talking to people, when they interview the plant operators, when they fill the tank, they filled it before they left. And they did that because they knew that if the next guy comes and the tank is empty, they get in trouble, right? Because they didn't have any other protocol. So the nice thing was that the students figured that out from talking to people. So this is one of my favorite projects because it didn't cost any money. We're doing lots of other projects which I won't talk about right now. One of them is electrifying the buses on campus. So I took it literally when they said 2025 carbon neutrality. I took it literally. I'm trying to educate the students to do that. That's all.
I'm Claire Napawan. I'm fortunate enough to be the second climate action champion from UC Davis, and I have to give mad props to UC Davis for selecting a second, and for the Office of the Provost and College of Ag and Environmental Science, as well as Harks for funding a second project. I'm going to be probably the shortest presentation today of all the climate champions, and I'll probably be the only one without a graph. So I was planning to say that, and then I didn't see a graph in Kurt's, and I got really worried, and then all of a sudden you completed that punchline for me. So I come from a kind of a very different field than the other presenters today. I'm a landscape architect and architect by training. My work is in participatory design, community engagement, digital humanities. And my efforts at addressing climate change sort of take a different approach. While the big sort of technological top-down fixes are important, we need policy, we need technology, we need infrastructure to address the sort of global scale that is associated with the impacts of climate change, right? So this is kind of just an image to show that, but we know this. I'm not going to talk at length about this, but this is kind of, you know, the big picture. Climate vulnerability on a global scale, and then on a global scale again, this is an image from COP21, the Paris climate talks that were signed back in November. Our project is sort of the inverse of that. It's an attempt to engage communities with the conversation of climate change, to try to diversify that understanding, to broaden and expand the communities that contribute to that dialogue. It's an attempt also to kind of reframe the way we talk about it from global scale to local scale. And so our project was launched about a year ago as a pilot funded by the University of California Humanities Research Institute. We partnered with the Institute for Sustainable Economic, Education, and Environmental Design, which is the acronym is ISEED, and they're an Oakland-based environmental justice group that integrates with local San Francisco Bay Area youth, particularly youth in vulnerable communities, youth of color, underrepresented minorities. And so we went to them with this kind of global scale climate information, but we also asked them, well, what are you interested in? Where do you live? What are the kind of experiences that you have with the projected impacts of climate change that you may or may not know? And we rescaled that vulnerability data to something that they could understand, that's something that was at the scale of their neighborhoods, their bus stops, their transit. And so there's an image there of us trying to working through the kind of implications of climate change in their area, within their region. So we showed them a range of maps, regional, local, even street view, and we had them literally put themselves on that map, figure out where they worked, where they lived, how they commuted, and really tried to show them the relationship between what their communities look like, how they operate, and a relationship to resilience and vulnerability to climate change. We also asked them, what are you interested in? What are the major concerns within your community, within your neighborhoods, in your schools and in your families? Because they might not understand, or a lot of the students and the youth that we worked with didn't understand the relationship, for example, of climate change and health, public health, or the relationship of climate change and race in urban areas, climate change and environmental equity. So we tried to draw those connections through the workshops. We had 2 day-long workshops. This is in the spring of 2015. And between that time, we asked them to use social media, something they were already engaged with, Facebook, Instagram, Twitter, to think about their own environments, the experiences they were having, and ask themselves, is there a relationship to what I'm experiencing to climate change? And if so, we had them tag it, Our Changing Climate. And it was kind of a unique experience, or a unique exercise. We didn't ask them to go and chase images of, polar bear habitats and, glaciers melting. We asked them to just live their lives, do the thing that they already do, which is post and tweet and photograph ad nauseum, but to just take a moment to layer over that a kind of critical thinking of, is this showing me an impact of climate change? Is this showing me a condition in my neighborhood that has resilience or vulnerability to it? What are the relationships? And then to use that as a way to kind of open a dialogue within their kind of social networks. So here's just an image of some of those posts that kind of arose within the first 6 weeks. And it was really fun. I'll just point out a few of these that were interesting. We had one student who thought she was going to go out and, take pictures of sea level rise and drought, and the truth was she found herself in a classroom quite often. And so she started just taking pictures of what she was eating. And then thinking critically about where that food was coming from and how far that travel was and what was actually in season. And so she started to build this dialogue between food choices and their relationship to greenhouse gas emissions. And so if you follow her feed, there's a wonderful sort of digital narrative that comes up with linking a personal act, behavior change, decision making with conditions of climate change. So we've started aggregating all of these posts, and I welcome you guys to kind of contribute to this. We have a website now, ourchangingclimate.us. It's sort of a beta soft launch, so don't be too critical on us. But if you have a chance and you're interested, please take a look. Also, please consider contributing to our network. We've actually developed these sort of analog prompts. They're sort of like scavenger hunts. They're based off of the 12 major themes that arose from our pilot workshops, themes such as flood, drought, food waste, infrastructure, health. There's a list of them if you go to our website. But we developed these little cards. One side gives us a kind of a resilient aspect of it, the other the vulnerable. And so if you take one, it's sort of your prompt to sort of as you live your day, you do your commute, go to work, work in your yard, take your kids to school, whatever happens to be. If you see evidence of that condition, whether it's resilient or vulnerable to climate change, you use this, you photograph it, and you tag it, and it becomes part of our network. So before you leave today, we have a stack of these scavenger cards at the front door. So if you'd like to grab one, that'd be great. So really what we see here is what we're finding here is that there's an opportunity to sort of engage a broader and more diverse community with these issues. It's sometimes hard for some communities to understand the sort of technical jargon associated with climate change. But by bringing it home and connecting it to their real everyday lives and drawing that link between what they are interested in and climate change, we can start to engage more communities in that effort towards adaptation and mitigation. And I'll just share two of my favorite quotes that came from the youth groups that we worked with in the San Francisco Bay Area. One of them said, "I now understand climate change in the small." And then another student said, "I used to think climate change was something for people smarter than me to talk about, but now I know it's about everything and needs to engage everyone." So both of these quotes are on our website as well as some others, but I encourage you to check it out, and I encourage you to all contribute to our network. Thank you.
Claire, thank you. And I want to just thank all of our faculty action champions. If we could give them all a round of applause. It's been really incredible. And just to remind you, this is only 10 of our UC faculty, so it gives you some window into how incredible an asset the faculty are to the system.